Hey guys, I want to talk to you today about the last 4 questions that we had on our Desmos yesterday. These are super important points about logarithms, so please get out your notebook and take some notes. Then, if you need to add to those answers that you had yesterday on your Desmos, go in and do that. I know I had one class that you didn't answer them, so I need you to go back and do those when you're done watching this video as well. So the first question we had was, what patterns can we find in our data? So for example, I have here some data. So when we had a log base 5, log base 3, log base 2, these were our x values. And something that I noticed was that each of our values is a multiple of the base, right? And so another group yesterday noticed that if I do 25 divided by 5, I keep dividing by 5, that's the pattern that I see. Same here. If I keep dividing by this base, that's my pattern. And same here. So the x values will always be multiples of our base. And depending on the direction of your y values, you'll see you're either dividing, or if you're going the other direction, you'd be multiplying. So that is a key, because with exponentials, the pattern we're looking for is multiplying or dividing. One thing we also pointed out is when we used a negative value, that was our last here, we had a -1 or a -2, our x values became fractions. And also anything to the 0 power is also 1. So some key things to think about. The next question was, what are some characteristics that all logarithmic functions have in common? So I'm going to put a few on my graph here for you to see, and then we can start drawing some conclusions. So these are all different logarithmic functions. So I think this is really telling to help us see some characteristics. So if you notice, every single one of these lines passes through the point 1, 0. So our logarithms will always have an x-intercept of 1, 0, because anything to the 0 power equals 1. It doesn't matter what our base is. Also, we saw that our lines are getting super close to the y-axis, but they never cross. So see how they're getting really close, but they never cross over. So there are never any negative x values. We will never cross this y-axis. There's actually an asymptote at 0, a vertical asymptote. So there is no y-intercept. That means that our domain is always going to be x is greater than 0. X is greater than 0. And it can't be equal to 0 because it's never going to even touch that line. It just gets really close. These look like they're touching that line, but they're just so super close that because if I even zoom in here, you can see, okay, they're really close, but they're still not touching that line. So that's key. They're really close, but they're not touching that line. We also can see that our range is going up and down. So my y values, my range is all real numbers. So those are all some things that we know about logarithms. The third question says, what have we learned about logs and inverses that can help us with this family? Well, we talked about how the inverse of a log is always an exponential, and an exponential's inverse is always a log. So if we are trying to solve a logarithm, we don't have a tool to put this directly into our calculator, so we can convert it to an exponential to help us solve. And our final question is, what happens as the value of b changes? So I'm going to get rid of my lines here, and we're going to look at b with a slider. So I'm going to graph that here. So this is our logarithm, and I'm going to change the b value so we can see how this changes, okay? So one thing I want you to notice, when my b value goes negative, is there a graph? Do we see a graph? I'll even zoom out. Is there a graph here? No. We cannot have a negative b value. We cannot have that. If we get into our 0 to 1 range right here, we can see that this is concave up, and my graph is actually decreasing, right? It's decreasing here. And the closer I get to 0, the closer it gets to the x-axis. The farther away from 0, the farther it gets away from the x-axis. Now, when I hit 1, again, I have no graph. So we cannot have 1 as our base value either. Because 1 to the first is 1, 1 to the second is 1. We wouldn't have any changes, all right? And lastly, now, when I get greater than 1, we can see that my graph now increases. So it flipped. But the same is true. The closer I get to 1, the wider it gets. The closer I get to, or the bigger the number I get, the closer it gets to my x-axis. So we can see here, as soon as I go back to a fraction, it flips. See that, how it flips? So those are some ways that our b value affects our logarithm.